In example number 9, we're asked to calculate the second derivative of 4 different expressions or functions. Okay, so let's go ahead and start with the first one. What I want here is we want to find, f double prime of x, which is the same thing. If we call this thing, let's just call it y. That's the same thing as finding d squared y over dx squared. Okay, like that. A lot of people don't put these parentheses around the bottom, so they'll just write it as d squared y over dx squared. So let's go ahead and compute that. We just have to take the derivative twice. So f double prime of x, well actually let's first, before I just jump right to that, let's calculate what is the first derivative. So this guy right here is, we call this the first derivative. Okay, and so what we need to do is we need to take this guy right here and differentiate it, so we get 4x to the third plus 6x squared minus 8. That is f prime of x, or with our notation it's being y, that is dy dx. So first derivative. Now the second derivative is f double prime of x, which is the derivative of the first derivative. So that's going to be 3 times 4, which is 12, x squared, plus 2 times 6, which is also 12, x, and nothing at the end. And so this is d squared y over dx squared. And so your units, now if your units were originally, if this was in like, if this was position and x was time, and it was like meters, okay, meters, if f of x was in meters, and let's say x was time, then f prime is meters per second. Okay, just like you would think of velocity, meters per second. Acceleration, though, the unit on top is still meters. Okay, however, the unit on the bottom is per second again. So this is per second squared, or per second. Okay, so the notation might be important for, the units might be important for you for your physics class. In the math course, typically, we're concerned with it, but we're really more concerned with this computation over here. So anyway, so this guy right here gives you your second derivative. Okay, your acceleration, if you're thinking about it in terms of velocities and position. Okay, now let's go ahead and take a look at the next one. We'll do it in a different color here. Let's do it in green. So part B says that we've got a function f of x, and it's equal to x plus 1 over the square root of x. So what we need to find, we want, again, the second derivative, f double prime of x, which is the same thing. If we call this guy, I'm going to call it a different variable. Let's call it z. Then that is dz dx. Just like that. So to calculate that, what we first need is f prime of x. Oops, when I said second derivative here, so we need to go like this. Okay, so f prime, the first derivative, that is dz dx. Okay, so we need the derivative of this guy. Well, we've got a situation here in which this is a quotient, so we'll take the bottom times the derivative of the top minus the top times the derivative of the bottom. Now the derivative of the square root of x we know is 1 over 2 square roots of x, and that is over the bottom squared. When we get to this spot right here, okay, we go ahead and reduce. So on the numerator, I'm going to get square root of x minus, it's going to be this guy over this guy. Okay, so I'm going to write it as, I'll do it as x plus 1 over 2 square roots of x. And now the square root of x squared is equal to just x. And you have to be careful here, because most of the times you should put absolute values around this, okay? Because the square root of x squared is the absolute value of x. However, it's a situation where in our original function we had square root of x, so we already had our domain set where x had to be greater than 0. And so since x is greater than 0, this guy right here doesn't need the absolute value signs. Okay, so we're not going to put them there, but just realize that you would normally have to, depending on the situation. Okay, so now let's go ahead and continue here. I'm going to get a common denominator up top, so that'll be 2 square roots of x. So I'll get 2 square roots of x times the square root of x minus the quantity x plus 1 over 2 square roots of x, and that whole thing is over just x. Okay, so now I've got the square root of x times the square root of x, which is just going to give me x. Okay, hang on one second. And so this up top right here, excuse me, gives me, again, square root of x times square root of x is just x, and it will be the absolute value of x, but we don't have to worry about that, minus this guy, so minus x minus 1 over 2 square roots of x. Instead of dividing the whole thing by x, I'm just going to multiply by 1 over x, because that's the same thing. And so this reduces to x minus 1 over 2x times the square root of x. And now this is to the 1/2, this is to the 1, so a quick side note, I've got x to the first, which is 2 over 2, times x to the 1/2. I add powers, so this guy is going to be equal to x minus 1 over 2x to the 3/2. Okay, now that's the first derivative. Now we need the second derivative. So this right here is f prime of x, or dz dx, because I called it z. Now we want to take that and we want to convert it. I don't want to say convert it, but now we want to perform the operation of differentiation again, one more time, on this new function. So f double prime of x is going to be, again, we're going to use the quotient rule. So it's the bottom, the denominator, the low times the derivative of the top, minus the numerator, the top, times the derivative of the bottom. So the derivative of the bottom, we multiply this guy out. Okay, so we've done this one already. Okay, so 3/2 times 2 is 3x. Subtract 1 off this x to the 1/2, which is going to be the square root of x, over this guy squared. So 4, now I got to square this. So when I square it, I get x to the third, like that. So let's go ahead and reduce our top a little bit. This becomes 2x to the 3/2 minus x minus 1 times 3 times the square root of x. And that's all over 4x to the third. So let's go ahead and just reduce this a little bit more. This gives me 2x to the 3/2 minus. Now, if I distribute this 3 square roots of x in, I'm going to get 3 x to the 3/2. I better put this in parentheses. Okay. Let's see here. Minus 3x to the 1/2. Okay, and that, excuse me, that gives me, so 2x to the 3/2 minus 3x to the 3/2 plus 3x to the 1/2, or 3 times the square root of x, over 4x to the third. And so this will give me 3 square roots of x minus, now this is just going to give me 1, so that's the minus, the negative 1, x to the 3 halves all over 4x to the third. And if we want to write these so they both have square roots in them, we can write this like this. This would be 3 square roots of x minus the square root of x to the third over 4x to the third. And so that is f double prime of x, which is d squared z over dx squared. Okay, so that, let's see how, we're on 10 minutes. Okay, this was a little bit longer of a video. We got 2 more to go. Excuse me. So that's A and B. So let's do C. C asks me, let me go ahead and scroll back up and grab that problem. Z asks me to, now this is the notation right here to take the second derivative, okay, of the following quantity. So 3x squared minus 2x plus 1. So to get that, the first thing we have to do is differentiate once on that expression. Okay, so that is equal to 6x minus 2. And then, so that's this guy. And then what we need to do is differentiate again. So watch how I'm going to write this. This ugly mess is equivalent to this ugly mess. And we know that this inside ugly mess is equivalent to this. So I have just ddx of 6x minus 2, which we know is 6. Okay, we got one more. Okay, let me just, I want to make sure that the text, we agree. Yeah, if we do. Okay. And so this last one here, we'll do purple. Okay, so for D, and if you're still following along, good for you, because this is a long video. So we need to take the second derivative of 8r squared plus 2r plus 10. You know, I should say this, and this is actually important. It is important what variable we're differentiating with respect to, because at some point, some of the variables, we're going to have multiple variables in here, and we're only going to find the rate of change with respect to one variable instead of the other. So it definitely does matter what guy we see down here at the bottom. So now I'm going to write this out like this right here. So this is dr of, dr of 8r squared plus 2r plus 10. And so this is ddr, okay, of, now we'll differentiate this guy, so we get 16r plus 2. These polynomials are really easy to do because of that power rule. Now we differentiate this guy again, and we just get 16 out. And so 16 is equal to this, or we can say that it is, we don't have a function here, I'm just going to call it f. If this was the function, if f was a function of r and it was equal to this, then we would have f double prime of r. Okay, or we could say it as d squared f over dr squared, like that.